Without any further ado, we're going to go ahead and get started with the roundtable. I really appreciate all you folks coming. Obviously, the word must have spread pretty effectively because this is a good number of people turn out for this. So basically what we're going to do, if you haven't been to the roundtable before, we do it online really pretty regularly. It's been a little less regular lately because I've been kind of insanely busy. So I apologize for that for those of you who do come, and there's certainly a few people here who do come to our event online. We are actually broadcasting it online, and we got about 16 people also in the chat here watching, and they can see and hear everything as well. So basically what we do with the roundtable is we do presentation of case studies. So we bring in folks, anyone who wants to present, who wants to put together a slide deck and talk about an interesting vehicle that they're dealing with or have dealt with in the past, and share their insight of how they got to the solution, or talk about all the headaches or the hurdles or things that were frustrating or something they discovered that might be useful. We all have different experience when we're dealing with vehicles. I think it's really helpful to share that experience. And, you know, not everyone has the ability to get out to large training events like this. So this is the reason I created the roundtable, was mostly to try and help those who can't afford to go to large events like this. And, you know, hopefully we can have more events like this grow across all the country in all the various areas where there are auto care associations like Mid-Atlantic Auto Care Association. It's really crucial that we provide this kind of event as many places as possible, because training is really crucial to our ability to keep up with the technology. And even if you go to 100 hours of training a year, I guarantee you, you're still not going to know enough. The cars are only getting harder and more complicated, and pretty much everybody here can probably agree with that statement. Before we really get started on the case studies, I just want to thank everybody who's helped make the live version of this possible, which one of the gentlemen in the back there, Ron, was a big part of being interested in bringing this to the event and making it possible. David, who also has helped with the whole production of this event, and all of the other staff that are here that have been you know, part of making a giant show like this happen. There's so many things that happen on the backside that make any of the large events possible. Sponsors, staff, you name it. I mean, it's so complicated. I would never want that job in a million years. So let's thank them, you know, give them a round of applause for everything they're doing. I also want to say thank you. So Ron, you got something to add? We also want to thank, I want to personally thank all of the folks that decided that they would come up here and present, as well as a couple of folks who are not here. One of them was here and he snuck away. I don't know where he went, but some sponsors, Josh Carton, who works for Curian N2 Neuron, the graphing DVOM, he gave away a couple of units to some of the folks who come to the event. Also Isaac, who has sponsored this from pretty much the beginning and tried to make it you know, more successful, shared the word about it and whatnot. So always appreciate that. We are interested in more sponsors, so if there's any companies that are interested in having some advertisement done, I want to use any money that's given via advertising to help technicians attend training like this. That's my only goal with this. Help other techs afford to go to paid training, because it's very, very important that you do. So for our presentation, we are going to do a handful of different folks are going to present case studies. We're always interested in all levels of skill for the roundtable. This is not limited to just the high level folks or anything of that nature. We really want all levels, because I think you can absorb a lot of information from these events, even if you're just kind of like one of my friends, a lurker, as he likes to call himself. Even if you're a lurker, it can still be really productive, because you can pick up a lot of useful information. So I really appreciate anyone who attends at any time, and you don't have to actively participate in, you know, talking or whatever. If you do, that's great, and we always appreciate that. But if not, if you just want to show up and watch, that's great. I do always try to put these up on my website, shotgundiagnostics.org. So if you miss one and you really want to go back and watch, you're always welcome to do that. I don't charge anything for that. I do try to get them up promptly. There's a few folks in Europe who actually message me after they know one happened, and the time differential prevents them from attending live. And they're usually messaging me saying, hey, is that other one up yet? And I'm like, okay, that was yesterday. I haven't had a chance yet. And rarely do I edit them in any fashion. So I would characterize most of the recordings as not safe for work if there's swearing policies, but we're going to try to keep it between the lines at this one. So these are our goals. We already kind of talked about that. I kind of get ahead of myself sometimes, but really it's all about case studies, and case studies are useful. And I know there's a lot of guys who go to training where that's literally all they live for is case studies, and that's fine and well, but there is more value than just case studies, right? So we try to do as much as we can with the material we have and the time we have, and we probably will run past our allotted time tonight, so feel free to stick around. These are just some of the companies that have helped make it possible, so I just want to say a thank you to them as well. If you haven't checked out this website, it is a really good website for training. So since we're at a training event, anyone who organizes training events, put your training events, send it to these folks. They put it on there. It's meant to be a centralized training calendar, and it is good for the industry because obviously centralized training is good. Easier to find it all in one place. That'd be great. I really do make an effort to try and help boost the knowledge and recognition of this site because we all want to go to more training if it's possible. And if there's one local, you'd hate to miss it, right? All right, so I'm not going to do a case study first. We're actually going to exit out. And one of the other gentlemen up here is going to do one. So we just, what was that? We're going to do those at the end. All right, so you are there and you can go into presentation. So I'm just going to switch chairs with Mike and he's going to present.
Thanks, Hawken. Can you guys hear me okay?
Yep.
Thumbs up? Yep. Okay.
I'm sitting next to you, so yeah.
Can you hear me?
Oh, yeah.
All right.
Got a
Good.
thumbs up on the digital broadcast too.
All right. Good deal. So you got to help me out here, man. How do I get to this slideshow mode on this? Everything
Should be on top, right? That's what she said. Should be up there. I think it's the far right one.
Yeah.
There you go.
All right. Okay. So I really like a challenge. So I take on all kinds of crazy stuff, and I know it's ill-advised. Something like this might show up in your shop, and I just wanted to demonstrate how I handle this because you switch it. So this is a 1974 El Camino with a big block Chevy 3-speed transmission. I don't know what you got going on here, man.
Is it not in presentation mode?
I don't know what it's doing.
All right. Let me take a look.
That better?
That was pretty good.
Okay.
There you go. You can zoom in. There you go. That's good. That's good.
But you're putting a stencil.
Fill the whole screen.
Yeah, I couldn't find the DLC anywhere. I looked everywhere.
No DLC. Oh, great.
Yeah. So,
Tailpipe.
so it's completely custom. It's basically everything's been changed on this thing. Stalls intermittently, always restarts. After a hot soak, it tends to be a little bit worse, but you let it sit for a few minutes and it starts right back up or starts and stalls. I don't know what's going on with this.
Just use the scroll wheel. Right.
Yeah,
Good
just
enough.
move it around.
Yep.
So I always start with an inspection because these things are terrifying, right? You know, this ends up in your bay. It's completely custom. It's an antique. You don't know anything about it. There's no wiring diagrams. There's no service information. So you got to have some kind of strategy. So the process I use is, obviously first we're going to ID the symptoms and then go do an inspection. So it's got a custom engine, aftermarket Edelbrock fuel injection, a standard ignition coil. I don't know why this messed it up, but so the ignition system.
You can just clip it on your lanyard.
Thank you.
That'll probably help.
Is that better? You guys hear me okay?
Better? Awesome.
Okay, so the ignition system, after quick inspection, it's got a distributor, ECU timing control, no vacuum advance. The ignition coil is controlled by an aftermarket ignition module. The distributor has a cam sensor mounted inside it. The ignition coil appears to be just a standard ignition coil. So it's port fuel injection. It's got an inline fuel pump. We inspected that. It looks to be plumbed properly. It's definitely an amateur built car. So, there's just kind of spaghetti wiring everywhere. Everything's done kind of okay, but everything could be better. After looking at the fuel injectors, you can tell it's a batch fire. So it fires one bank, then the other based on just the wire colors alone. Now, it could be a sequential fuel injection, but more than likely not.
It looks like it's overfueling.
Yeah, for sure. Yeah. And it's got a vacuum operated fuel pressure regulator mounted on the fuel rail assembly. I don't know why this did this.
Uncooperative technology.
Yeah. Well, it changed all the slides.
It did?
Yeah. Yeah. Like none of this is right, but that's okay.
I love computers working against us, right?
Yeah, we'll get through it. Okay. So the problem with intermittence is, where do you start? So I don't like to get rabbit trailed too far, so I like to go one step at a time. So the fastest thing for me to do in this case is, since we only have one ignition coil and we have one power supply for the fuel injectors, I put an amp clamp on the injectors and an amp clamp on the coil, and then took it out for a drive. This is what I ended up with when it stalled. So I lose ignition coil control first. So I know my chances are my ECU is not shutting down. Chances are I'm not losing fuel. I know I'm dealing with an ignition problem or an ignition control problem. So now I can tackle that side of the system and figure out what I have going on. So I hooked the scope up to the ignition system. I have the ignition coil feed, the ignition secondary lead. I'm monitoring the cam sensor and the ignition coil, or the ignition module ground. So right away I notice something weird going on with that ignition coil feed. Has anybody seen anything like that before?
Can't see the side of the it's on the screen, so they're gonna have a hard time seeing.
Oh, the scaling.
Oh, what is
that?
Dude, I don't know what the crap is going on with that. No, I can see the scaling. What are you talking about?
No, you can't see. Hold on.
You gotta move that. It's that. It's
Yeah.
not you. You gotta move that back.
Oh,
What back?
It's full. It's on the wall.
Yeah.
It's running off the screen.
Yeah.
Oh, the projector.
Back.
Oh, I was like, what are you guys talking about? That one? All right. This must have gotten bumped or something. No, you're right.
Yeah, it was on the
It's too big.
projector
That's
side.
not what you usually hear.
Behold technology.
Didn't you say this is a family event?
That's what I thought.
That was good. That was good.
That was good.
Super.
Okay.
All right.
So
Much
now
better.
maybe that'll help you with the scale. So anybody have any ideas what's going on there? Well, it's not a ramp. That's the ignition coil feed. So that's voltage on the feed for the ignition coil. Right. Pretty significant, right? Almost half. So on a 1974, I'm sure there's enough people in here old enough to maybe know what's going on with that coil.
Hey.
I was born in '87, so I had to sit and think about it for a little bit. But
Ouch, that hurt.
sorry, man. So that's what a ballast resistor looks like when it's loaded. So that's a 6-volt coil. So when that's loaded, it pulls the voltage down to near 6 volts. So, point style systems use that. It's kind of rare to see anywhere, especially on a scope, of course. But so it threw me off for a second. And if I know I have a problem with the ignition, and I'm possibly dealing with a pretty old component that cycles every time the ignition's cycled, I want to see that ballast resistor before I go any further. So I go looking for it. I can't find it anywhere. You're right. So I let it sit overnight, cycled the key on. I used a test lamp to load that wire and let it sit there and used a thermal imager to try to find the ballast resistor. What I found was this is the wire going up over the brake booster to the coil.
Whole thing's pretty warm.
Yeah, so the whole thing's getting hot. And actually, once you pull the wire out of the loom, you can see that's actually the resistor is built into the wire. Now that's not, I did look into the factory service information, and there is not really any mention of it for what I could find, but the information's pretty limited on a 74. So, so that all makes sense. So that rabbit trail's done. I know I wasted maybe 25 minutes, half hour, and it's an intermittent, so I had no problem letting it sit overnight. So now I did leave the same leads hooked up and took it for a drive. And then when it did fail, you can see the feed voltage drops low. And it, obviously the secondary cuts out, but the cam sensor feed stays steady and the ignition coil ground is steady.
So which channel is which? Just one of them.
So the blue is ignition coil feed, green's the secondary, red's the cam sensor signal, and yellow is your ignition coil ground, or ignition module ground. So now I know something's causing that voltage to go low, and I doubt it's the resistor wire. Oh, hold on. Yeah, I don't know why it did that.
Thanks, computers.
Yeah.
They got minds of their own, right?
So I do have a wiring diagram. And so this is wired as the factory car as far as everything except for the ignition module and the cam sensor and the distributor. So you can see there's an extra wire coming off the positive side of the coil going down to the starter. Anybody know why that would be the case? Right, exactly.
Thanks, buddy.
Yeah, thank you.
All of us with gray hair, we're ready to answer that one.
Yep. Right, so that's so you get battery voltage during cranking.
And for all the young guys in the room that are used to dealing with, like these old interactive wiring diagrams, this is what we had to grow up with, all right?
Yeah, and that was on paper. So
Some 3-year-old drew it with a black crayon.
That's what I was getting ready to say, man. It was all in crayons back
so
then.
I went to this setup. So I'm on the blue is ignition coil feed voltage. The red is an amp clamp on the wire that goes between the R terminal on the starter and the ignition coil. The green is the signal wire for the starter solenoid, so you can see when I'm cranking it. So this is good. This is normal. I have the vehicle idling. I shut it off here where the voltage goes low. And then this is key on. And then when I'm cranking, you can see the amperage on, or the current on the starter signal goes high. And you can see the current actually goes low on that R terminal wire. And that's the current flowing into the ignition coil during cranking. And this is a normal event.
I'm just letting other people in.
Okay. So I finally got the thing to act up. And this is what happens when it breaks. So again, I had it idling. We got it good and warm in the bay, shut it down, tried to restart it. So this is key on. This is while I'm cranking. You can see because the current goes high on the starter signal. And then when it starts and stalls, you can see the current goes high on the wire from the R terminal to the ignition coil. And when that happens, the voltage goes low at the coil. And I've got a much better example. So that's actually what, this is the first one where I caught it. And then we were actually able to reproduce it about 4 or 5 times before the thing just wouldn't stall again. And I want to demonstrate the difference here. So you can see with the key off, the voltage is at 0. With the key on, while it's shorted, while there's high current on that wire, there's a very small amount of voltage left at the coil, but there's no current left to actually make the coil work. So you can see as soon as you let off the starter, you let off the ignition switch, it pulls that coil right down to 0 and it stalls the car. Anybody have any questions on this? I just want to make sure this makes sense. Okay. So after visual inspection, make sure we didn't have any other problems. We verified that this is actually the starter causing the stall. Going down the road is extremely intermittent because it would cool right off. And basically it would only act up driving through town, or if you slowed down, stopped at a stop sign for a few minutes, went to take off, then it would stall. So that's actually what we ended up finding was the R terminal here at the starter was getting pulled right down, and it wouldn't blow any fuses because of that resistor wire. So that's the end of that. Any questions? All right. Well, thanks. I don't know how to get out of this. Yeah.
All right, so sorry about the technical difficulties to Mike here. Apparently the stupid program decided to change his slide deck, which is really not cool, and now it's not wanting to get out. So, wow, don't we just love technology when it doesn't work?
You're in,
right?
you're in.
You're locked in, you get no choice. There's no changing. I'll give, you want to go next?
Sure.
All right, so.
Great
I'll have him
presentation,
come on
Mike,
here,
thank you.
and we have to switch over to Corey's presentation. So here's your clicker. You are good to go.
Hold on. Woo-hoo. All right. All right. I told Hawken, let me go first. This way, start off real weak and let it get better as it goes on. But thanks. All right. So for those that don't know, I'm a mobile tech, mobile diag programming. And the reason I preface that is because things get a little bit different when you're mobile. For those that do the diag work or any diag work, it can be challenging to begin with. Getting information, getting your equipment together, and trying to do it mobile makes it more fun. And going into a shop that's not, I don't want to say cooperative, but not not cooperative, or the environment is not cooperative, makes it way more difficult. On a time schedule, trying to get to the next car, all of the stuff that goes along with it. So this particular shop calls me up. This is also an example of why when shops call me and say, what time are you going to be here? And I say, I can't tell you what time because I don't know how long my next car is going to take or the car after that because I don't know what's going to go wrong. This is an example of that. So I get the call from a transmission shop that says, we put a transmission in this Ford. We need you to come in and program it. I says, easy enough. I'll be there. I'm figuring I just got to roll in, do the calibrations, the strategies, and I'm in and out. I get there, and I will preface this by saying, because I'm trying to paint the picture, and let me digress a second. This case study isn't so much about it being technical. It's about the struggles that we face as technicians about trying to get a diagnostic process together, get a game plan, stick to it, and then people are throwing diversions at you and problems at you that you start to question your own process and make you go off track. And you end up, as Jim Morton says, you got to get into the diagnostic funnel. And as Brandon Steckler says, rabbit holes look a lot like diagnostic funnels sometimes. And you find yourself off course, off your procedure, off your process, and realize you're in a rabbit hole. And usually it's, well, it's your fault, but because there was other things thrown in your way, and this was part of that. So I get to this shop. This shop is actually 3 businesses in one. It's a repair shop, 3 different businesses owned by different people in one building. So
Sounds like NYC.
yeah, this building is long and narrow. I don't know if you can tell from that first picture, but I'm about 10 bays deep from the front door. The first 9 are an auto repair business. The back, I want to say 6 bays are a transmission shop, and somewhere in there, there's a guy that rents a bay and fixes ATVs and motorcycles. I'm working around all these guys, and they don't always get along, which is why my truck is not inside at this truck. It's outside because I can't even get in there. No big deal. I grab my laptop. I get in there. I grab my VCI. I get in. The owner says, oh, yeah. Oh, by the way, it doesn't start. But that's just because it has to get programmed, right? God, really? So I don't have my notes in front of me, but I'll wing it. So now I know I'm going to be, here's what goes by being late for the next call. I scan it, and sure enough, I have no communication. Excuse me 1 second. I'm going to grab my notes.
Good.
Sorry.
Notes are helpful.
Yeah, my notes are helpful. I did write this about 9-10 months ago, so forgive me.
I can be a refresher too then.
Yeah. So I scan it, and yes, and I'm old. My memory's not that good. So I scan it, and sure enough, I don't have communication with the PCM. So let's right away, of course, I'm looking at my watch. I'm trying to come up with an idea. I'm looking down. That tunnel is me looking where my truck is and all my equipment. And I'm like, oh, man, what do I need? What am I going to grab? I don't want to do this in 20 trips. I want to do it in 1. I really want to get out of here. I got a full day ahead of me. So what do you grab? Right? Right? You start thinking, right? What are we grabbing? Quick game plan. Keep in mind, usually for me, when I'm approaching these cars, when I go to a call, I'm on my way, I kind of have an idea about what I'm heading into. And while I'm driving, I'm going, okay, when I get out of the car, I'm going to grab this tool. I'm going to grab this, my breakout box. I'm going to grab my voltmeter. I'm going to grab whatever. I wasn't ready for this. So now I'm trying to think quick. Whoops. Yeah, see, I hit the wrong one. I hit that one. So I grab a wiring diagram. I'm thinking, I already got my scan tool. I can get on the real quick, pull a diagram. I'm thinking these guys left a ground off. Right? I'm winging it. They probably they put a transmission in. The shop's known for doing stuff like that. They don't have a regular installer. They kind of have an installer, whoever's available that day to put a tranny in, kind of thing. This is probably, and I'll give it a little help here. This is probably where I started going off track already. Hindsight being 20/20. A lot of guys are looking, going, "That's a good idea. Probably happened." What's the game? What's your diagnostic process? Did you do it? Am I sticking to it? Probably not. And you'll see why. So I grabbed this real quick. They probably left the ground off. I'm looking at, I don't know if we can see it at the, do I have a mouse on this? I do. I'm looking at this lower left corner. Oh, look at that. I'm looking over here at this G104, this G111. I'm looking for something, actually more like G104. And it's right there. And it's on there and it's tight and don't look like they ever touched it. Now what? Now I pull out the diagram. Maybe they pinched the wire, blew a fuse, something silly. Grab a diagram. I'm looking. Let's see if I can bring this up where you guys can see it. I'm looking right over here. This glasses,
You can use
fuse.
the highlighter on the pointer,
Wow,
the top button.
that
You
one?
can point it right at, no, you can point it right at that screen, actually.
Now what did I do?
You would hit the forward to the backward.
Okay.
So that was the very top button. There you go. But
Oh,
yeah,
look at that.
You gotta hold it.
Oh, there you go.
Yep.
Well, that's pretty cool. As you can tell, this is my first time doing this, so. Fuse 32, fuses are good. What else was in there? I can grab fuse 12 because, well, if the PCM power relay is working, I should have power over to fuse 12, fuse 26. Simple enough. I check it all. And I see I went too far. And they're all good. I wanted to stop here, go, now what? My fuses are good. My ground is in place. The PCM is buried in the left front wheel well. Wheel's got to come off. Cover's got to come down. What are we grabbing? Anybody?
Are you only losing communication at PCM or are you?
Only the PCM. Which is actually, no, I'm sorry. No. I lost communication with everything. I should, the whole bus is down. The whole network is down. You can see I'm off track already, right? I went squirrel because I'm pressed for time. I'm thinking, anytime you say think or maybe, that means you're about to guess. Take those out of your vocabulary. Take it from me. I don't say think. I don't say maybe. I say it should be, what is my next test? What am I looking to prove or disprove? When you say, I think it's going to be, maybe that means I'm going to guess. Don't guess. It's not what we think and know. It's what we can prove. This is where I was at. I said, I think they did something when they put the tranny in, which I may be right.
Look on the wiring diagram, figure out what is the communication wires, check the resistance first, then go to a scope.
Thank you. Guess what I didn't do? I pulled the PCM down instead. I'm going to check power and ground at the PCM. I find the most interesting, I shouldn't say it, the stories I want to share the most are the ones I screwed up because I don't want you guys to do it. So, like I said, it's not terribly technical, but it's how quick we can go off track and go the long way to a simple decision, to a simple diagnosis. This was one of those. I pulled the PCM down. I checked powers and grounds right at that plug. And of course, you can't check it while it's plugged in because it's upside down. And you know, it was easier. Pull the PCM out, check powers and grounds. And thank you, Ford, for putting so many green wires in one plug. It was unbelievable. I said, really? Yeah.
Are you colorblind too?
Yeah, no. Powers and grounds are good. Now I go, all right, now I stop. I literally step back, look at the car and go, I'm in a rabbit hole. I need to stop. I need to go to my truck. I need to get back in my game plan. I'm going to get my breakout box. I'm going to get my scope on a rope. There's the breakout box. There's my little scope on a rope. And if you can't see it, there's a steady 5 volts on the high side of the network.
Uh-oh.
You gotta be kidding me. Actually, if I go back, you look closely, that's 0 volts on the low side, right? Because I'm plugged in right there, and I'm 0. High side, I'm 5. I just wasted a whole lot of time chasing the wrong thing. I got off track. I got in a rabbit hole. I didn't follow my process. I let the shop. Yeah, unfortunately, yes, I did. Now let's start on the right track. Now I grab a CAN network diagram. Oh, I got the button here, right here. I need to find a place real quick where I can get to it, where I can maybe split it. I can find out where it came apart, where it's getting pulled down. I go to, actually, this is part of it here. I want to try to find somewhere in here, one of these connectors, I can pull this network apart.
I like a GM with a splice pack.
Right. 214, awesome. It's in the center console. I don't want to go for that. Let's keep going further down. I like, oh, where's C2, where's C, yeah, let me see 210. There it is, C210. That's buried up under the dash. Maybe, but I don't think so, and I don't want to get under there. C133. Ooh, under the hood. I can get to that. And look where it is. Right by the transmission. Somewhere around this battery. This, for those, everybody knows these escapes, they stuff that battery way underneath the cowl. Yeah, it is somewhere on the side of this battery, buried under there. There it is. If I know the angle's a little tough, there's the actual where the plastic snaps in. Give you an idea on the left side of the battery. I pull it apart. I identify it. That is the plug I'm looking for. Before I go any further, look, it woke up. That works back up. So now I know. Now I'm going to go back real quick. It is somewhere in here, right? I unplugged this, and the rest of this woke up. It's somewhere in here. What I need to do now, real quick. Which way do I go? Yes, but which end of the plug is it? For those, does anybody know how to tell which way to go? The diagram actually shows you. If you look carefully, see the little arrows on the connector? It's kind of hard to see. Right at the connector, there's a little, looks like a little airplane. Those actually tell you the direction of the male and the female connector.
I don't know if I've ever noticed that.
That actually tells you which way to go. So it's not guaranteed which side it's on, because I could still be crushed at the other end. But it's now that I took it apart, it's no longer shorted, depending on which wire is shorted. I grab this left side right here, and I can, real quick, this goes down to the PCM. I can kind of grab it, I can pull on it. Cool, I grab this other side, I go to pull, and it's stuck. I can't see it, it's buried under the battery. I can take the battery out. If I take the battery out, it kind of defeats the purpose, because now I can't see the network. I really want to leave the battery in. Got my hand stuck under there, and I can't feel nothing. I want to make sure this is the next slide. Yeah. So, network wakes up. I can't see under there. I grab my borescope real quick. Try not to be invasive, right? I don't want to inadvertently fix the problem. I grab my borescope and I stick it behind the battery. Yep. There it is. When they put the battery tray back in, they crushed the harness right there. Between there's the battery tray, the battery tray and the frame, and they crushed it right there, and they broke it.
You smack them?
Now I pull the battery out, I open it up, I fix it, I put it back together. Yay! Program it. Do the programming, which took a whole 7 minutes. Wasted about an hour and a half. And but that was my
And you build them, right?
I did build them, absolutely. Well,
Not your fault.
so I mean, I started off right by saying, yeah, it's probably something they did, but that exact comment is what threw me off, because I went, oh, it's probably something that I should have just followed my process. And that was why I kind of wanted to put this case study together, because it's what threw me off. I said, I think, maybe, I used those words, and stick to your process. Make a diagnostic process, write it down if you have to, stick to it. And that's it, guys. Thank you.
Thank you, Corey.
Taking the microphone back before I start incriminating myself.
This is all being recorded. You want to go next, or
What was
do
the
you want to go
penalty
next?
for all that?
I'm
You wanna go
sorry?
next?
What was the penalty for all that?
Man, great job.
I couldn't get yours to open. I tried like 3 times. I went into Gmail and it's saying like it won't let me open it. You got a flash drive you want to plug in?
I can try. I don't know why it won't.
Or let's try it again.
Did send it.
Give it a shot. Maybe it'll work this time.
Yes, it's gonna work this
You get out of the way.
Now I think we're good.
time.
Okay. I'm gonna clip one onto your lanyard there, and we will put you in presentation mode. You can use the clicker and you can use the spotlight button to highlight things if you want.
I got.
I like the leader. Sure. That's nice.
Right? All right. It's a little case study that hopefully give you some different diagnostic approaches for testing some circuits.
Check to make sure no one's trying to get in.
I'm also a mobile tech, so I get to see a lot of different things, but I'm also a college instructor, so I get to do some of these case studies for my class. So I try to save a lot of them. This was a really good shop. These guys know what they're doing. This wasn't one of those shops you go to that's a hack. It's an older truck. There isn't a lot of technology here we're going to cover. It's just some different testing processes. There's no big wow fix at the end.
Spoiler alert.
Yeah, spoiler alert, right? But how we got there and how they got off track and being able to show them how to stay on track next time is kind of worth the time, right? So it's a 05 Jeep. It's got a Hemi in it, 130,000 miles. It's actually pretty clean. I'm from upstate New York. I was amazed that the thing was still clean. It's got a bunch of new parts. They've had it for a couple weeks, probably closer to a month. Sitting there in the parking lot. Won't start. It'll start, stall. Sometimes it won't crank. It's got two codes in it. They've messed with it. 2100, which is a throttle motor circuit fault code for the motor. Pay attention to that. And a 2111, which is a throttle unable to close. Throttle unable to close is going to set anytime we got a throttle motor code because it can't close the throttle. So the throttle body's been replaced 2 times with OE, and they're like, look, here's the OE one. Showed it to me in the nice Mopar Stellantis box.
Because the first one's always defective.
The first one's always defective, right? So it's got to be bad. It being a Mopar, it could be, and I'm a Dodge guy, but you know, their electrical stuff is not okay. So that didn't fix it. They tested all the wiring, checked fuses, sent the ECM out for a rebuild. They send the ECM back, they put it back in, same problem. So they're like, okay. They didn't do something right to rebuild. They send it back. The rebuilder opens the ECM, and this is where things went way off track. The rebuilder calls them, says, this ECM's so bad inside, I can't save it. I'm going to send you another one. Well, how did you send it back the first time if it was that bad inside, right? Right? So they send it back to them. One of two things happened here. Either they didn't open it the first time, or there was really nothing wrong with it, and they're guessing because they didn't know how to check the ECM. So they take the ECM, they send it back to him the second time. The tech's pretty sharp, goes in there, scans the ECM, can see the previous VIN in the data. And it was a different VIN than the one he has, but his truck has the correct VIN that's matched to the ECM now. Same problem. What are we going to do? Right? Let's launch the parts cannon, take everything we can, get it off the part shelf, and that doesn't fix it. Punt. So customer states all power and ground to the ECM have been tested, including voltage drop testing. They're okay. I don't take any weight in that at all, because if you did that and you still don't know what's going on and all those new parts are in it, I can't believe what you're telling me. They sent the ECM out. We talked about that. Same issues with the placement module. We talked about the VIN. So the tech goes one step farther. He says, okay, I'm going to do an overlay. Snips the harness at the ECM, snips it at the throttle body, does an overlay harness. Just on the motor circuit, this is only a motor code we're dealing with, not TPS motor. Same problem. So he's ruled out the wiring. What's left? So he goes into the service information. We talked about the 2111. That code sets because it can't close the throttle. The 2100 is the one we got to kind of focus on, right? There's a circuit fault with the ECM, or between the ECM and the throttle body. A circuit fault is either an open wire, shorted wire, or excessive resistance. Let's focus on this code, right? So we got to create a diagnostic plan. Where am I going to go with this thing? I don't want to put another code part in it. They've already got 3 in it. They even changed the connector at the throttle motor the day I was there, just before I got there. So let's do strategy-based diagnostics, right? Anybody's ever read a GM service flow chart? It has strategy-based diagnostics as the first step. Review this chart.
right? You can move some of those steps around, but some of those steps have to stay where they are. And the first one is it acting up now? Yes, it's acting up now. Did you do a visual inspection? Yeah, I did. It looks pretty good. Do you use the TSBs? Is there any TSBs? No TSBs for this problem. I didn't expect to find any because he's been all over this truck for a month. What are we going to do? Use the flow chart, right? Should I punt, get out of this thing because I don't know what I'm doing? Maybe I should have, but let's keep going. So here's the flow chart, right? It's simple. Check for shorts and grounds on the 2 wires that run between the ECM and the throttle body. It's easy. You're going to check, make sure the wires aren't shorted together. We're making sure they're not open, they're not shorted to ground, they're not shorted to power. But when you read a flow chart, how many steps are in that flow chart to make those tests? About 20 steps. Check wire A for an open, check it for a short to ground, check it for a short to power. Check wire B, same thing. Check between the unit and the module for excessive resistance. There's 2 more steps. It ends up being about 20 steps. I'm old, I'm lazy. If there's a way I can cut a corner, I'm going to do it. So these are only 2 wires, right? So who's the commander, right? Who's in charge? The ECM. The ECM sends out the signal to the throttle body, and the throttle body does its thing, opens up, lets more air in the engine. If the air can't get in the engine doesn't rev up. This is what's set in the code. And it won't start because the ECM knows there's a problem. And if it starts, the throttle could potentially wide open and cause some injury. So its default is don't start. So we can go through this test, right? We can check each wire to ground, check each wire for voltage. How am I going to get around this quicker, right? So I do. All of those circuits test fine. I don't have any problem with any of these wires. I got 3 ohms at the throttle body. Specification for the throttle motor is 3 to 25 ohms. That's expecting what I expect to see. Disconnect the throttle circuits from the module and use a meter to measure the current flow. Wait a minute. This is how I like to check things. When I check electrical circuits, I go back to Ohm's law. I current test anything I can current test because if I have a voltage problem, what's it going to show up in? My current. If I have excessive resistance or too little resistance, what's it going to affect? My current. And what's always going to stay static? My voltage. And unless it's a resistive voltage circuit, it's going to be battery voltage, right? So if I have 12 volts, 12.86 volts, whatever, I can write that down on my paper as my first number. I know I've got 12 volts. Then what? Operate the circuit. If I operate the circuit and measure the resistance in that circuit, I know, or the current in the circuit, I'm now going to know what? Resistance. I told you they gave me a specification of 3 to 25 ohms of resistance for that throttle motor. So if I command that throttle motor on at 3 ohms of resistance, at 12 volts, I should get about how many amps? 4 amps. So if I take and power up that throttle unit at the ECM connector and ground the other side of the throttle unit at the ECM connector, now my voltage leaves the connector from the ECM through the harness to the throttle body, back through the harness to the chassis ground, I should have how many amps? 4. I have about 3 ohms of resistance, 12 volts in battery. Quick math tells me I'm an idiot. 4 amps. Somewhere around there, I'm happy. I do that. Guess what? It's 3.8 amps. Do I have a wiring problem? Do I have a throttle body problem? Where is my problem? PCM? Probably, right? We tested all these. They can all carry some current. We're going to review what we did. It's a mobile diagnostic call. I got to make a plan from here because I am not calling another PCM. These things are impossible to find a new one for. I'm not making a call on it. Where does that throttle motor get voltage from? Does the ECM make the voltage inside of it magically? No. Where does it come from? Battery, right? It goes through the battery, through the ignition switch, wherever it comes from. The voltage that gets applied to the throttle unit has to come from the battery. But how do we know which one of the ECM voltage feed circuits are the ones that are going to supply the throttle motor? What's that?
Check all of them.
Check them all. So I check all of them. I can do that. If I want to narrow it down, I can make some sort of a decision on what wires might feed a throttle motor. Number one, is a throttle motor probably going to have switched ignition or battery voltage? Switched. We were going to shut that off when we turn the ignition off. So I'm probably not looking at a battery wire. I'm looking at a switched ignition feed wire. So I check all the switch ignitions to the ECM, right? I find my 2 ignition feed wires that go to the ECM. I check them, they're 12.2 volts. I voltage drop them, they're around 105 millivolts. So I got 12.1 volts, 150 millivolts on the other wire. Do I have an issue with that power supply and those 2 switched ignition sources? No. Same thing there. I got 2 grounds. Could be a bad ground, right? I got 2 total grounds in this PCM. 2 total grounds lead the PCM. And look at them, they're 14 gauge and a 16 gauge wire. They're pretty heavy grounds. They're doing a lot of work inside that ECM. I back probe the ECM. I have a 100 millivolt drop on the grounds. And then I check from the battery positive to the ground at the ECM. I got 12.1 volts on the ground. Is there a ground problem feeding the ECM? No. I'm thinking more along the lines now, what have I got that's bad? PCM. I don't like being wrong. So all causes except for the PCM have been eliminated according to the trouble code diagnostic information. Do we really think at this point installing a 3rd PCM is going to fix this thing? These steps right here are the steps that's in the flow chart for this, narrowed down, right? They give us our abbreviation, then they tell us how to check each one of these circuits. They're telling us how to check all the throttle motor circuits. They say maybe low battery voltage can cause that. They tell me the ETC motor throttle can cause that, or a PCM. They don't even tell me to check any of the feeds for the PCM. I've already gone further than the flow chart has. We talked about that. So I don't think the throttle motor gets the voltage all the time. It's a switched power feed. I've checked those 2 switch power feeds. They check okay. Yes.
On some Nissans, it's a battery power feed, because when you shut the ignition switch off, a couple seconds later, it actually.
Correct.
That would be battery power.
I agree with that. I'm making an assumption from me. You're 100% correct, because I have a couple Fords that'll do that. You'll shut them off, and then 10 seconds later, it does a self-check, and then you walk away and it's gone. So we'll check the battery feeds too. How can we determine which one of these wires definitely is what's feeding the throttle body? I could put an amp clamp on it, but I can't. So what do I want to do with the amp clamp?
You turn that ignition switch on, you should see it move elevation. 2 lamps on, one at the throttle body and one on that battery power body. See the match.
I love that because I love checking current. I have one problem. I have a motor circuit fault code. The PCM won't turn on the throttle body, or cannot turn on the throttle body. So if it can't turn it on, or it won't turn it on, is there going to be any current? Exactly.
You can't tell if you have a current problem, it doesn't send voltage there. So if you're sitting at it with the scope, looking at it with the clamp, you're gonna see something real quick.
I'm going to see a little bit of some sort of action. If I see some action there, then I got to measure the voltage, right? Because if I have a voltage drop at the PCM, I can still see that voltage and current change at the throttle body when it first goes to check it. I agree 100%.
You also jump in a smaller input cycle.
Right. I can. Here's my thinking. And these are all steps I can certainly do, but so far what I've done with one's the back one. Going the wrong way. I want to go backwards, sorry. This test right here, I've checked everything from the module to the throttle body, right? So at that point in time, am I going to gain anything by putting a light bulb out at the throttle body?
Tests from like PCM output voltage towards the throttle body back to all of your 12-volt units. Kind of over, you know what I mean? To see which one creates certain pattern.
I can. That involves a lot of
Yeah.
checking a lot of different circuits.
Well, just within that PCM volt.
So you're saying, how can I determine which wire is
Which
feeding?
one is your feed in of your 12 volts?
I can. I definitely can. Hang with me for a minute because I'm going to show you something that I kind of discovered on this thing that made it somewhat simpler for me to make an assumption as to what's going on here. So at this point in time, I've got two things that are causing this problem. I got a feed problem to the PCM or a bad PCM. It is not on the output of the PCM. I'll lay my life on that.
Silly question, Bob. Did you?
Pin test the terminals? I did.
Okay.
My AES wave test kit, my U-test terminal kit. So how do I determine which wire from the PCM actually goes in the PCM, right? So say we have 4 voltage feeds inside a PCM, right? We have 4 total. And I have 20 outputs out of that PCM that require voltage. How do I know which circuit is going to get which voltage supply? Unplug each one, see if I get the blip on my motor action. I could do that. I have to go back and find each one. That's perfectly acceptable. But it is a lot of work. And like I said, I'm lazy. I'm old. I tell my students in class all the time, I'm lazy, right? If there's something I can do with a scan tool, I'm doing it because, man, if I got to get out under the hood, it's a bad day, right? So how can I get to this thing as quick as I possibly can? So we need to determine which motor wire feeds this thing. So look at this quick. I'm going to step it up a little bit just because I know there's other people that want to get involved here tonight, and I don't want to take up everybody's time. Here's my motor to the throttle body, right? I got 2 circuits, a dark blue with a light green, a dark blue with a gray, right? Simple 2 circuit wires, just like Corey showed us earlier. This right here, this little V, what kind of terminal is that? That's female. I come down to here, this little V right here, that's female. I get some cool stuff out of this diagram. Circuits K126, 18. What is 18?
It's the gauge, right?
It's the gauge of the wire. I got an 18 gauge wire going to that circuit. Why? Because it carries 4 amps. What's that? There you go. So I'm looking for a feed to the PCM that's going to be at least 18 gauge. So if I start going through all my powers and my grounds, going to this PCM, now look at this one over here. Here's one of my ignition switch feeds. It's what gauge wire? 20. Is that my wire? Unlikely, because it's smaller than my 18 gauge wire that I need for the throttle. What about this 18 gauge wire over here? Possible, but I'm not going to buy that it is, because why? It probably feeds more than just the throttle body, right? So I need something larger than an 18 gauge wire, which is going to be 16 or 14. There's only 2 labeled ignition inputs to the PCM. You look at this PCM, there's only 2 feeds right here on the bottom. Fused ignition switch, fused ignition switch. I have 2 battery feeds. I didn't put them in here. They were also 16 gauge and 18 gauge. So I agree with you that maybe I'm thinking now that maybe it is the power feed right from the battery. One's 18 gauge, that's not it. It's the 20 gauge, that's not it. What are we missing? I'm missing something here. I get down to the pull out my wiring diagram, I look again, and I have fused ASD relay outputs, right? Relay for the ASD is what? Switched or constant power? Switched, it's a relay. ASD is going to be switched. But can the PCM switch the ASD relay on after I turn the key off to do what? Enter with the throttle body. So that is a switch source that can act like a battery source because the PCM can turn that circuit on even with the key off. Maybe that's my wire, right? Because that can do my throttle check after I turned it off. I look at this wire coming out of the relay. On this wire, it's 16 gauge. I get a little bit better picture of that. Backwards.
Oh, you're giving it away.
I know, right? Stop. Don't spoil it. Don't spoil it. Yeah, I already did. I told you it's not a big fix, but what I want you to get out of this is how do I know what wire feeds what circuit inside the PCM? I need at least the same gauge wire or heavier to get in the PCM. I don't even need to go check those 20 gauge wire feeds to the PCM because that's not going to do my throttle body. So the ASD is switched by the ECM. It only appears to feed external PCM circuits when I first look at it, fuel injectors and coils, but I follow the two wires down to the PCM right here. When I come up here, I'm sorry about the crummy picture, I got two 16 gauge wires coming out of my ASD relay through this fuse into the ECM. This is the other wire. That's the one that feeds the coils. All that does is feed ignition coils. Same thing. Here's a close-up of the one of the wires that goes to the PCM, 16 gauge. We can see that there. I got you a little bit better picture. Do I think maybe I've got my right wire here? I mean, it's easy for you to agree with me now, right? Because I'm probably giving it away, right? That's all the students are like, I'm gonna in the class. So I check the voltage supply to that wire. It's what? 5.63. Am I on the right wire? Yeah. But now I got to find out where's the problem with this wire. It's 5.63 volts at the PCM on the ASD relay. I'll be 100% honest with you. I'm not perfect. I first started this. I know, right? Ask my wife. She'll totally tell you that. Could be. Bad connection to relay. Bad connection in the harness. Anywhere, right? I got 5.63 volts there. Check the other side. This wire goes from the battery through the relay and the switch coil side out to my PCM and my ignition coils. I could check the ignition coils. I can check the fuel injectors. I can do all kinds of tests here. I'm lazy. I got 5.63 volts there. I pull the ASD relay out. I shove what in there? A jumper. Guess what happens when I shove my jumper in there? 12.2 volts. What's bad? Do I need to check any wiring? Voltage drops, anything. Am I done? I'm out. That relay is bad. I unplug it. It's 5 volts. I plug in my jumper. It's 12 volts. I don't need to check anything else. There's the actual shots. That's where I checked it at the PCM. Over there, that's the actual meter reading of what I had at that relay. If I want to verify that when I get done, I can voltage drop check across the relay while it's on. I put my extension in there, put the extension in the fuse box, put the relay on top of it, measure across the coils 30 and 87. I get what? 6.4 volts. That's the remainder of my 5 volts that I missed, 12 volts that I'm missing when I have 5 volts. 5.8, 6.4 gets me around 12 volts. Guess where it's all being dropped? Inside the relay. And these guys missed that at that shop, and I don't blame them one bit because you could follow that flow chart for 2 weeks straight, and it never once tells you to check the ASD relay circuit. It doesn't tell us what's turning on the throttle body, where it gets the feed from. So I hope you got something out of that. I installed a new ASD relay, performed the throttle learn, it's all good. Service information was lacking testing procedures. Using Ohm's law, I could easily figure out what current I needed to supply to that, what size wire I needed, So which wire is gonna be feeding the PCM? Just thanks. I hope you guys got something out of this.
Thank you. Heck yeah, thanks.
Thank you very much. Really appreciate it. I enjoyed the tip about looking at the cages of the wires upstream. That was a good idea. I don't think I've ever thought of that before. So, hey, I learned something. I appreciate that. So, the next person we're going to have go is Andrew Fisher. So he's going to do a presentation. I'm going to get his slides set up here. So stand by for a moment. I might trigger his PTSD as I get this one ready. So. How you guys doing? We're good. Flip around or hold it either way, buddy. All set.
You guys hear me all right?
All right, so how's this thing work? What?
Just a normal clicker, and that's the way up the top.
Guys, I can't sit still. If you've been watching me up here, I've got 80. I'm jumping around everywhere. So I'm gonna walk through a little bit like it's clear in the class. You guys got questions? Because you're gonna see a lot of mistakes in this.
Can't hear Andy.
Real honest with you guys, going into this is a failed process case study. If you guys read something on the reporters yesterday, you would see I'm a big stick around process and I failed myself here. So that's what this is.
Can't hear Andy.
Oh, they call on
His beard is filtering it.
I have an extension lapel. I can grab it for you if you want.
It's your beard, it's filtering.
Good?
Clipping on his beard.
So what we have here is a 2016 Buick Cascada with a 1.6 turbocharged engine. You guys seen this 1.6 in any other GM platform? Out of curiosity, has anybody seen the 1.6 in any other platform other than this one?
Hawkins still can't hear. It's too muddy.
A lot of second guessing going on here in this case study, so I'm gonna put that out there right now. Okay. So it's a 1.6 turbocharged, 105 spins on it. This car has actually been to our shop numerous times in the past. We have quite a bit of history on it. So it's not like we go into this thing one. Okay. On the 20th, the vehicle comes in with multiple codes stored. I want you guys to see them up there. We got a high voltage sensor 2. I've got a link code and I've got an under boost code. More importantly, all of my monitors have ran and passed. That's key, guys. Anytime you are dealing with any sort of drivability issue, you need to be checking your monitor status. Why do I want to check my monitor status? Absolutely. Because how many times a customer, client, whatever you want to call them, brings the vehicle in and says, I've not had this anywhere else. And you know dang well the battery's been disconnected. This proves it. Not only does it prove it, it covers yourself as well. Because if I've got a vehicle that comes in, multiple monitors haven't ran, and as I set the monitors, other codes set, it's not an ever since you anymore, is it? I got documentation to cover myself. Fair enough? All right. I'm going to be honest with you guys. I never intended this one to turn into a case study. I thought this was going to be a very, very straightforward vehicle. This ended up turning into about a 3-week process. And when I say 3 weeks, it left, it came back, it left, it came back. Okay. Unfortunately, my eyes suck, so I got to walk to the front here a little bit. All right. When the vehicle first showed up, I was adding 40% fuel. Total fuel trim, 40%. A whistling noise was heard from the valve cover area. What kind of product am I working on? Yeah. If you guys haven't seen this product, though, this is not a plastic valve cover. This is an aluminum style. Okay. When I put a vacuum gauge on the dipstick, I've got 2 inches of vacuum. You guys that work on domestics, is that alarming? That I got stuck. This is tunnel vision right here. 2 inches of vacuum. I'm having a serious issue with this. I don't do a lot of imports, or I'm sorry, Europeans on purpose. This didn't seem right. I kept going back to this, okay? Rear oxygen sensor constantly is reading over 1 volt. Big red flag, isn't it? What's 1 volt indicate? Runs rich, right? And my fuel trims are kind of backing that up, right? Because I am doing what? I'm adding 40% fuel. It knows it's a high voltage issue, but I'm still adding fuel. Kind of odd, right? What's that? Absolutely. So it's doing the exact opposite of what you would expect, right? Keep that in mind as we move forward. What's that? I'm sorry, my hearing's so bad, Tim. Hold tight. Hold tight. I'm not giving it all away just yet. Calculated airflow and MAF are off. Guys that work on a lot of GMs, what's that indicate to you? I got a vacuum leak, right? Now remember my symptoms here, guys. I've got 2 inches of vacuum on the dipstick port. I hear a whistling noise. I got some fuel trim issues. What are you going after at this point? I did. If I took the oil cap off, it would suck it right back down. The noise would go away on this visit. Okay. Going down the road, this car runs absolutely perfect. Runs perfect. Fuel trims plus or minus 5% total. I wish I would have kept the data on the initial test drive. Like I said, I never intended this one to turn into a case study. It happened after the fact, unfortunately. Okay. So based on the symptoms, and I'll be honest, guys, I work at a very high volume facility. There are days where there's 2 of us that do strictly diagnostics in our shop. There are days each of us does about 15 to 20 cars a day. High volume. Things got to come in and get out, and we get them out to our repair techs as fast as we can. Okay, that's our job. We've got to feed the repair guys. So I make the call. I thought this was a pretty straightforward issue, right? We're going to put a valve cover on here, and I'm going to put a downstream O2 in it as well because of the high voltage. I cannot get the high voltage to change. It doesn't matter if I force a lean condition. I cannot get it to change. It doesn't matter if I try unplugging it. Remember that. When I unplug it, I see what I suspect is bias voltage. Remember that moving forward. Little did I realize how much I missed. Biggest issue is I did not do any of my follow-up tests after the repair was done. We are sticklers about doing verification tests. But let's be realistic. Corey was talking about being in the shops and he's trying to get to the next job. When you're working on 15, 20 cars a day, dude, I ain't got time for it. Get it up front. That's unfortunately what we do. Now, vehicle returns a couple days later. Customer states it's doing the same thing. The original customer complaint was the vehicle is surging. They pull up to a stop sign, the vehicle surges. That is their initial complaint with this vehicle. Codes are checked, and my heart sank. I knew. You guys ever get that gut feeling? You pull the car in, and you're like, oh, man, I didn't follow my gut the first time. I better start following it the second time, hopefully. Fuel trim code has returned. Notice it is the only code in the vehicle right now. I'm so focused on that lean code. I'm in my gut, I keep telling myself, I overlooked something or I got bad parts. So during the testing, it's noticed that after a few minutes, I kept going back to the purge valve. I don't know why. I think it was just the pattern failure, silver bullet. Knowing GMs have a ton of issues with purge valves. All of a sudden, I get that thing to stick. I do not suspect this is my only issue, but it is an obvious issue that I need to address. Purge valve, back ordered. No ETA. So I unplug it and I cap it for right now. I don't want to cause any more issues. What I forgot to put up here is my calculated and my actual MAF are off yet again. I take the oil cap off the valve cover, boom, sucks it right back down all over again. I never had the noise come back. Never had the noise come back. But I got the same symptoms, right? On this particular vehicle, everything is done inside the valve cover. There's no separate hose. So I'm kind of limited, right? Do you hear the whole high volume part? He says that on a BMW, they'll put a plate in, he'll lift the valve cover, put a plate in, put it back down. I don't have that luxury. Mark's sitting here on the end here. Mark knows, he owns a shop by us. He knows how high volume and how many cars we push out of there. Do I ever have time for that kind of stuff? No. Huge parking lot, we never have any parking. Okay, so I want you guys to see the design of the valve cover. Everything's built in. Now, if you look in operation of the PCV system, it will break down all the components of the valve cover. I'm not going to bore you with it. But more importantly, when I start reading, I see that a damaged pressure regulating valve could cause rough idle, stalling, oil leaks, or high idle speed. I'm matching a couple of these symptoms, right? I suspect, right out of the box, I've got a bad valve cover. I know, right? Insanity. Take the car on a test drive. After replacing that valve cover again, the fuel and O2 monitor set. I have no codes pending. Fuel trim's going down the road and at idle currently, about plus or minus 5%. Are you guys good with this? Would you let the vehicle go back to your client? Yeah, I think a good majority of us are saying, yeah, if we pass the monitor, what did the monitor do for us? Yes. The rear O2 at this point is reading correctly. At this point. Okay. I think I fixed the car. No surging is felt. Vehicle's returned. Yeah. No. No. I still have the purge capped off. The client knows the issue. They know the check engine light is going to come back on. And I'm going to be honest, we were very upfront with them. The underboost condition is a concern, but I will never chase an underboost condition when I can create boost. The car had plenty of power until I get everything else situated. Like that's just my rule. I will never chase an underboost condition until everything else is running correctly. Okay. So 10/6, so October 6th, vehicle comes back, still stalling at idle. And it is noted that the rear oxygen sensor is stuck high again. I'm out teaching a class for CTI at this point, so I'm not back at the shop. My good friend and the other diagnostic tech, Jeremy, looked at the vehicle, shoots me a quick text. He's like, man, that Cascada's back. The rear O2 is stuck high. I can't get this thing to move. I'm going to go ahead and put some O2s in it. I agree. I do. I agree. Yet again, puts new O2 in it, takes it for a test drive. O2 and fuel monitor set plus minus 5%. Are we good? You would think. What's that? It is a trick question. I remember what I said. This is about a 3-week ordeal. Guys, if you guys do a lot of drivability, if you guys are, how many in here do mobile? Quite a few, right? When you get a car that kicks you this hard, how do you feel?
Destroyed.
Oh, man. The words I want to say right now I won't do because we're being recorded, but I'm second guessing life. I'm going to be honest with you. Like, how am I missing things on this vehicle? It's not possible. A few days later, 6 days later, car comes back. Unfortunately, I do not have a thing for CTI, so I'm in the shop now. Yes, every time a component is replaced on a GM product, I guess I should put it up there. Good point. It's one of those things, you do it all the time, you don't even think. But yes, the fuel trims were reset on this vehicle.
Was boost really low?
No.
But it was
Desired natural always matched, and the vehicle would run. When this thing runs, it runs. I mean, for a 1.6 turbo car, they get up and scoot.
So you never experienced low boost, even though it threw coach low?
Never, ever. And I will tell you right off the bat, I never got that code to return. Pre-scans perform because it comes back. You notice, what codes do I have? Just my evap. Is that what you guys would suspect to have? I mean, I got it disconnected. I'm going to set some evap codes. That is all I have. If you notice, all of the monitors ran and passed. Here we go, guys. I love putting quotes and goofy things in my classes because it kind of brings the human element into it for me and doesn't make me feel as stupid as I felt at this time. But the definition of insanity is doing the same thing over and over again, but expecting different results. What's that? Well, it may be true in some instances, right? Like if you're learning a musical instrument, lifting weights, practicing a sport, that may not apply, right? You're going to keep doing it and doing it and doing it, and eventually you will get different results. In a situation like this, I don't think I'm getting different results, right? So at this point, I'm insane. I can't sleep. I keep researching the vehicle. I get on all the forums. I make phone calls. Nobody has any insight. Again, how many of you guys have seen a 1.6 outside of a Buick Cascada?
Never.
I researched. I can't find it in anything else so far. So if anybody can prove me wrong, I'd love to hear it because I honestly have not found it. So there's not a lot of info out there, right? Car comes back. They say it's doing the same thing. I pull it in the bay. Well, let me rephrase that. I take it for a test drive first. Car runs great. Pull it in the bay. It's sitting there and idling, and it's idling for a few minutes. I think total maybe have been about 15 minutes. Starts running rough. It's sitting there and it starts surging. I pull the oil cap, whoop, right back down. What is it safe to say at this point about this particular crankcase and PCV system? It sucks. I'll be honest, I had to call Hawken, and I was talking to him about it. What did you tell me? A boosted vehicle, what do you normally expect to see?
Well, it depends on the application, but you can see 2 inches of
Yeah.
vacuum in the crankcase, and it's not a huge shock sometimes.
But I work on domestics for the most part, and this just doesn't seem right to me, okay? Now, I want you guys to remember, what code did I have initially on the first visit? Besides the 171, what else? 138, the IO2 code. I'm going to be honest with you guys. I should have spent a little more time here. Ignore the fluff. But it states that the ECM detects the heated oxygen sensor voltage is greater than 1,050 millivolts, and the circuit is shorted to voltage. I think what that should say is that it could be shorted to voltage for greater than 15 seconds. Remember that spec. Do you guys see this okay? I know sometimes we have a hard time getting this to show up.
I can tell. It's good.
O2, you guys were asking about the front O2 earlier. About 0.84 millivolts. We good there? What's my rear O2 reading, which I'm losing here in the light? Bank 2. Where do I start out at? Is that a red flag to you? You guys that work on a lot of domestics, does 1.9 seem right on initial key up? I will tell you on this vehicle, that's pretty close to bias voltage. 1.7 to 1.9 seems to be normal on this car. But I want you to notice, how long does it take to come down? Kind of odd, ain't it? Now, what have we replaced so far? The O2's been replaced. The rear O2's been done how many times? Twice. Front O2's been done how many times?
Once.
Keep that in mind.
In your capture, how long was it stuck there? High voltage. You could see it in the picture, but I couldn't see the time scale.
I hate Snap-on's time scales. When we actually timed it out, I think when we were on the phone call, I think we were counting up to 30 seconds at times.
And it still didn't flag it.
And it still didn't flag it.
Thank you, ECM.
Yeah.
You do your job poorly.
Did it do it poorly or is it doing it correctly? As in, I'm sorry, maybe I don't understand.
It's calculating point, what is its reference, potential voltage level problem somewhere else?
Well, it wants to see it drop below 1050, right? 1050 millivolts. but it never states in anything with service information what the bias voltage would be. I will tell you when we check it unplugged, 1.9 to 1.7 is normal. Fair? Remember those numbers. So we know the O2 is reading high again. And just so if there's any questions here, guys, this is not an air fuel car. Okay, this is not wideband. These are two O2s, old school style. GM didn't think it was worth putting a wideband in this one. Okay. The upstream showed low and then it climbed in that initial read. Did you guys notice that? And if you notice, this is key on. This is after I started the car. I guess I should have put. I don't have RPM, but I got engine load. You can see it. You guys notice that though? What does the rear O2 do the minute within seconds of the car starting? Went way up. You guys that work on a lot of GM products, what do you normally see after a key up on a front O2 or any O2? And depending on the temperature, I will see that thing go down, right? Very rare do I see it shoot straight up. Normally you can watch your heater work, right? Depending on temp. So there's a whole bunch of stuff here I'm just not happy with. Notice the fuel trims. It got as low as negative 33 on the short term. So there's a lot of big red flags there, isn't it? What do you notice here? When the car actually starts running and it's in closed loop, what does the O2 do it? Do you see a full swing? It's doing something, but I'm not switching fully, am I? Kind of odd. It is. It is. Big red flag, right? Now, I wish I could tell you all the puzzle pieces were starting to come together. I would be lying to you. I've made this statement about 20 times this weekend talking to people, but I'm going to state it here. I have no problem being the weakest player on the best team. I don't need to be the best player on the worst team. So I start making phone calls. Thankfully, my network's good. Most guys sitting at the front of the room here. So I noted all that with the O2s. It's towards the end of the day. I'm done. I got to walk away at this point. About 15 other cars to come in still for the day anyway. Talked to the client, told him, hey, you know and we know we got a very odd problem here. I need some time with this vehicle. So far, so good. They're understanding. As the fuel trims trend negative, the fuel rail sensor will start going high. We're going to see that here in a second. That is a very important piece of information. If I've got a direct injection system, right, direct fuel injection, and my rail sensor goes high as I start surging, what is it safe to say is happening with the injectors? Probably shut them off, right?
Cutting fuel.
Cutting fuel. We're in a fuel cut condition. Remember that. I cannot get these O2s to react very well at all. Guys, I'm the king of propane. I go through like 1 or 2 containers of propane a week. I got no problem using propane as an alternative fuel or trying to find leaks. I'm cranking this thing open, trying to get these things to react. I'm creating vacuum leaks at the brake booster. It takes forever for these guys to move. Calculated airflow and mass airflow today read the same. So what is it safe to say? I don't have a vacuum leak. Look at my O2s. You guys notice what happened this day? 1.9, pretty close to 1.9, 1.84. The rear one, or I'm sorry, the front one drops pretty quickly, right? Takes a second or two for that rear one. You see how we're trending? You guys thinking anything at this point yet? Just out of curiosity. I want to see. Nobody? Good. I don't feel as stupid.
Make me feel better, right?
I'm gonna be honest with you guys. I was telling these gentlemen last night, I was like, man, I'm really nervous about presenting this case. Because this car kicked my butt for quite a while. And if somebody sits in the back of the room and tells me what's wrong with this car within 3 minutes, I'm walking out.
Take over. I'm done.
So if you notice, fuel trims start trending high on the short term. What's my long term doing? Trending down. Guys, right about here is where I start getting the surge. Where are my fuel trims at when the surge happens? And you can always tell when the surge is occurring because of what the fuel rail pressure sensor is doing. When you see that guy go high, this thing's like wanting to stall in my bay. And then all of a sudden it cleans up. Do you see that? Cleans up. I get a little bit of activity out of the O2. This time I was able to catch it a couple times. What's a normal pressure reading on a direct injection GM at idle? About 500, sometimes maybe 7. Again, there's a couple of dependents there, but are you going to see 11, 12, 1300 PSI at idle with no load?
No.
What am I seeing there?
Insanely high.
Insanely high. What's it safe to say if I had to put the injection pulse width on here, what would be safe to say?
Almost nothing, if not nothing.
I never said I was a smart guy. I don't always grab the PIDs I should. Again, this was never intended for this type of, I never intended this for a case study. Now, all of a sudden, I've got some switching. But what do you guys notice? What are you guys seeing? Fuel rail pressure is good. It did surge a little bit. You can catch that right there. You can see it in the fuel trims. You can see it in the rear O2. But what do you notice about the O2? Anything kind of, there's not much movement there, is there? Okay, so let me ask you guys this. I'm going to tell you right now, I'm already kind of devising a plan. What would you do next? Knowing what you see here, what would be your next test? Unplug the electric one? That's a good idea. I'll be honest, I didn't do it. What else would you do? So I'm going to tell you what I did. Is the rail sensor my issue, or do you think the rail sensor is a result? And why would you say it's a result? Just out of curiosity. I'm going to tell you why I think so. Let's see if we're on the same page. My fuel trims have already been making adjustments prior to that guy going up, right? To me, that is a reaction. I don't think it's the cause. Fair enough? Any other ideas here? Thank God. Whew.
You check the pulse modulation for the plunger on the pump?
I'd never touch anything with the fuel pump. I'm going to show you why here in a second. Because that was going to be my next go.
No, the mechanical pump, the pulse modulation.
The solenoid. I never checked it. But remember, I don't suspect I have a fuel pump issue of any sort. Because the fuel pump, judging by what the rail's doing, is a reaction. What's that? It's making pressure. So that's my thought. I mean, it's a good idea, but this is my thought right now. I don't feel I have a fuel issue. Are we safe to say that? You guys good? We on the same page here? For the high pressure or low pressure? Yes. They do. Until the surge happens. But again, I suspect I'm going high on the rail because it's the result. Does that make sense? Because I'm shutting the injectors off. You guys follow me? Are we good there? Notice again, all of a sudden, this was key off, key back on. What does my O2 do?
Way up.
Does that react like any, and if you notice, where's my fuel trims? The car's not running yet, guys. This is key on, engine off. But my O2 went up. Kind of odd, isn't it? Would you expect it to go up that way? Out of everything you've seen in the past in your career, would you expect key on, engine off, the O2 to do that? Yeah, me neither. At this point, my thought process is is I'm not convinced the PCM is actually seeing what the O2s are doing. Would you agree? Do you think maybe the O2s are actually doing one thing, but the PCM's seeing another? How would you check that? God, I wish I would have done that, but no, that's not what I did. I'll be honest with you. The other night, I'm laying in bed and I'm like, I bet if I'd have done this, this car would have been gone on visit 2. This is when things take a turn. Remember, we were talking about the Jim Morton funnel effect, and sometimes it becomes a rabbit hole. I'm digging halfway to China at this point. I want you to pay very close attention to the screen right here. Uh-oh. There we go.
Lag.
There is the scope hooked up to the O2. What do you guys notice? Can you guys make out? Ooh. Oh man, this is. I'm the least technical or tech savvy guy out of the bunch here, so this is exciting for me. I got it to work. What do you notice the numbers there? Anybody? Can anybody see those? Yeah, I'm about 0.5. I can get it down to where? About 0. I'm playing around with it at this point to get that to happen. But do you see much change in the O2 with the scope? I'm sorry, Tim, my hearing's so bad. I am on battery ground. I'm using the ATS. Okay. Here's what I will tell you. Who in here uses an ATS scope?
Me,
Do you guys also have a Pico? Do you guys also have a Pico scope? What I should have done. Again, I never intended this to turn into a case study. I should have grabbed the Pico. You guys agree with that? We kind of had this conversation. I wonder now, looking back, if things would have been different. You know, it's like that bad ex-wife. What could have been? Guys, I'm sorry the screen shows up so bad. What I'm going to do, hopefully it'll show up. When I put the scope in, is right here. Right about here, I start stabbing the scope in. If you notice prior, 0.4 volts is about where I'm at. When I put the scope in, where do I go? Oh. Oh. What are you thinking? Dave, you're over there. Aha. So I'm doing this at the O2 connector. I'm doing it at the front O2 connector. So you're thinking maybe bad terminal tension? Is that what you guys are thinking? I'm gonna make a lot of guys upset right now. I don't back probe. You would think, right? But just so we're clear, I don't back probe. And no, I don't live in the South anymore, guys. I live in the Chicagoland area. I pierce everything. Why? My buddy JT next door pierces everything too, right? Yeah, I don't want to influence that terminal in any way, shape, or form. And I've done it multiple times, and I've been burned by myself multiple times. I pierce.
Where's the location of the boost pressure sensor?
The boost pressure sensor was in the intercooler, if I remember right. Because you guys asked me to unplug it. Yeah. It's right at the intercooler, down at the bottom. I don't remember if it's on the intercooler itself or the tube right there. We thought that wasn't the case because we spent hours on the phone. I disconnect my scope. What happens to the O2? Gets weird again. What are you guys thinking? I am affecting the circuit. So what are you thinking? Bad ground, bad power. So most likely a ground is what I'm thinking, right? I'm gonna be honest with you. I load tested every one of them. What's that? It shouldn't, should it? Did it? There's a better picture of me with the ATS hooked up to it. I just wanted you guys to see I am able to move, but even with the ATS, am I ever going high? I should have paid attention to that. So here's what I know so far. I got my ATS scope hooked up. A shift is seen in the oxygen sensor data. And I want you to know, if I start having a surge on the vehicle, if I stab the wire with the scope, I make the surge go away instantly. Instantly, the surge goes away. So what are you thinking?
The scope hooked up to the car.
Leave the scope hooked up. That's $6,000. It may have been cheap. I'll be honest. It may have been cheaper in this case. Okay. I think they're making fun of my ATS, but whatever. If the car runs rough and I stab the scope to the lead, I use a Phil's probe right on the signal wire. If I put my scope into it, I can make the surge go away. Guys, what do you think at this point? You're thinking power ground something, right? And if I tell you I checked them all and I did a load test on them and a voltage drop test, and I tell you right now they were all good, where do you go? Remember, I am,
Back internal.
I will tell you this, I
PCM.
pierced on both sides and I get the same result. What's the chances of that though? You know what I'm saying? What's the chances of this happening, right? So it will stabilize and smooth out. This is only happens with the front O2. Does not make an effect if I do it to the rear. I see a whole bunch of you guys go, oh my God. That's how I felt.
Gotta be a
What was
ground.
that? Wrong sensor?
PCM supply ground problem.
Hold that thought for a few minutes, please. Disconnecting the O2s makes no difference. We've done all the service on this vehicle. There's no history of any major mechanical repairs. It's been oil changes, brakes, and tires, if I remember correctly. Disconnecting the O2s makes no difference. Thanks to the gentleman in the front, Scott Hicks, John Dickerman, who's not here, and Sean Hill. They talked me off the edge numerous times. If you guys are part of that chat group and you heard me talk to the group, you would hear like total excitement one day and like, dude, I'm ready to quit the next.
No more cars.
We do confirm bias voltage. If I remember correct, Mike, was that John that made the phone call to his buddy, or was that you? I think it was too. John's got a friend, something with engineering with GM, if I remember correctly. If you're listening, John, you can tell Hawken. That is correct bias voltage on this vehicle. So this is where networking is awesome. I'll be honest, one of the biggest reasons I come to these events. Make friends. Because I'm not as smart as I think I am at times, and I need people smarter. Hold that thought. Just hold that thought.
Andy, it was Sean.
It was Sean. He confirmed. Thank you, Sean. All right. I did not think that way. So to me, if it looks like a duck, it walks like a duck, it quacks like a duck, it gets an ECM. Because think about it. I've got new O2s. My powers and grounds are correct. It sees that. Disconnecting the O2s makes no difference. I'm going to be straight up. I pulled the trigger on a computer. You know why? I'm going to tell you why. I think it was $215 in stock at GM. I'll eat it. At this point, I'll eat it. On the ECM side, yeah, I did to confirm bias voltage and nothing was changing. I did scope the signal, the reference, and the ground. I'm sorry, the signal and the ground, and we checked the heaters. So we checked all four with the scope. That's, again, I didn't save any of it because I never intended this to be this bad. This is where you want to be an instructor and you don't know how. Save everything. And the problem is I'm the least tech savvy guy you're ever going to meet. I just recently learned how to put an arrow on, was it paint or whatever? That's how bad it is, guys, okay? Why do I got Michael Jordan up there? I thought it was a slam dunk for the ECM, right? No. I love this Michael Jordan quote. I told you guys I like to put little Easter eggs in there, right? Basically, what he is saying here is his successes are based on failures. Don't get discouraged like I did.
How you explain when you connect the scope for the signal to be correct?
We're going to get that here in a second. I'm trying to talk myself up here. This is moral support for myself. All this slide proves to you guys is this is the ECM put in, and I still got the same crap. Same crap. Again, I'm being recorded. I don't want to repeat exactly what I said. Hawkins laughing because he heard it. Okay, it was bad. I'm done at this point. I'm done. So let's go back to the drawing board. My friends remote in. Thank God for modern tools. We hooked up both the Snap-on and the Phoenix Smart just to make sure we weren't having a scan tool issue of some sort. And these guys have me checking a whole bunch of stuff. I know we were looking at boost pressure. We were looking at throttle actuation. Like we were throwing out some really odd ideas initially. We ignored the O2s because everybody thought, including myself, maybe I went down the wrong rabbit hole. Or in this case, digging halfway to China. If I could have got the cartoon thing of the coyote digging to China, I'd have put it up there. Okay. Lots of testing, lots of scoping, realizing a huge testing flaw was made. Remember what I said? I'm the worst player on the best team, and that is okay sometimes until it's not. Remember, I said I unplugged the O2s, right? And I checked them. I unplugged one, I plugged it back in, I unplugged the other. See what I'm saying? Unplug, nothing changed, plug it back in, go to the other, unplug, nothing changed. I didn't. Big flaw, and I'm okay with this. Learn from me, please. I put a lot of time into this car. I didn't talk to my wife or kids for like 2 weeks. And not because I didn't want to, it's because they didn't want to talk to me. Okay, they knew, they could see it. Okay. Talking with my friends up here. We make a call. And the call is, let's order 2 new GM sensors. Not Delco, but GM, straight from the dealer. Is there a difference, guys? Oh my God. What we got there? That's my new front O2 plugged in. What do you guys notice? Am I switching? Am I going 0? Am I going 900? I can't see from here. I'm half blind. Give me a second. This is at idle. Does everything seem to look pretty good to you besides long term? And I'll explain that in a second. Everything looked pretty good. This is key on, engine off. What's my O2s doing now? See how he goes up, but it only goes up to about 900. What's the front one do? He stays low. Car's fixed. So here is the question. Did I fix the car on the first visit? Did I fix the car on the first visit? I fixed the damn car day one. I got bad parts.
Sure did.
Do you guys see that? That W on that O2 sensor is not for winning. That is not Dorman wings either. It is a W, and that's all I'll say. These came out of Delco boxes. I guess I'm not so stupid after all. Normally, if I have a bad O2, this is an unpopular opinion with a lot of people, but if I have a bad O2, on that bank, it gets both. I don't play that game. You're going to get them both or I'm not doing it. In this car, I put just the downstream in. My buddy Jeremy, knowing how we operate, was like, hey, dude, you never put the front one in there. I'm going to put the front one in there for you on good measure. I don't fault him. Not at all. He fixed the car. Did I do it again? Is that the last slide? Can you hit it? I don't remember if I put another one in there.
Nope, that's
That's
the
it.
last one.
New parts in a box were incorrect.
New, never ever worked.
It did, and it made no difference. Remember, and I know there's going to be guys go, man, you didn't do the learn. That's why my long term was so high still. I never did the learn. And I did that on purpose. I just kind of seeing what was going to happen. You got a question, sir? Guys, what's happening right now with parts? I'm not here to make accusations, but here's the problem. A couple things. Guys buy parts and put the old junk back in the box and send it back as new. And some manufacturers are buying parts from other manufacturers and putting in them their boxes, marketing them as their own. Hard to say which way this went. Crazy, isn't it? To me, trying to think logically and keep it simple, keep it simply stupid. I plugged the scope in. My friend back here said, hey, do you think you have a capacitive issue? Absolutely. Absolutely. That O2 was built incorrectly. A little bit of resistance of my scope changed the game. Yes. 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 But me being in a panic, and I have no problem admitting I made a fault here, was like, well, hell, everything's there. Everything I need is here. It's got to be a PCM. This is a logic issue, right? Yeah, no. So be careful. Make sure you're paying attention to the part you pull out of the box. That's it on this one, guys. Thank you.
Well, I enjoyed watching all of you suffer through that one with Andy because I watched the whole thing unfold and tried to help as much as I could, as many of us did. Yeah, that was quite the interesting one and quite a curveball. So let's all pray we never experience that, right? But yeah, you will, right? And it's kind of ironic because my case study is actually also about aftermarket parts. So through a little bit of a different lens, I'm going to try clipping this on. We'll see if it works. All right, so you can hear me good, right? So ironically, right, the beginning of the slide is literally, have you been burned by aftermarket electronics? Well, we know someone sitting right over here who just was, right? But here's the thing you don't know about why this happens, right? There's a reason why these parts don't perform like the OEM part does, and it's because of patent laws. So when the manufacturer contracts a company to manufacture a part, there are patents that manufacturer and also the OEM own that patent. So if an aftermarket company, like Walker in his case, wants to engineer that part, they cannot make it exactly the same as the OEM because they would violate the patent. That means they would get sued and they would not make any money at all. Now, that's also another reason why you'll see, for instance, Bosch on an O2 sensor, if they don't make the OE, you will sometimes find an NGK or Denso or another brand of sensor inside the box. That's really important to know because it's not always bad if you find that. There might be a reason for it, and it could be a good reason. Bosch is at least smart enough in those situations to say, hey, we don't make that one. And rather than make a crappy copy or imitation that's not going to perform, we'd rather just buy them from the people who make them for the OE and pretend they're Bosch and, serve the customer. So just something to think about when we're talking about parts. The other thing I want to think about and point out to you is when you're thinking about aftermarket electronics specifically, we want to know what's the complexity of the system. Is this a sensor or an actuator? So if it's something that's a basic raw voltage output like a MAP sensor, there's a possibility the aftermarket one might be able to be re-engineered to work because all it's outputting is a raw voltage, right? That's something that they can probably make it work. But if we're talking about something like an actuator, it has to electromechanically respond in the same way that the OEM one does. That's harder to accomplish by re-engineering the entire circuit. So I always like to ask if I'm going to explore aftermarket, or like Andy said on that purge valve, hey, it happens to be on national back order. Well, it's bad and you need a new one, right? Well, could we check and find out who made the OEM for the OEM? Something to entertain. And of course, if you've used any of the European parts suppliers like SSF or WorldPack, you know that they will label that in their system sometimes. Hey, this was the OEM supplier. So there's a better chance that it might in fact actually work. Well, yeah, in some cases. Well, and that's another thing to keep in mind. So there's a good example of that. So for instance, Volkswagen Audi used to use Bosch coils on a bunch of their vehicles. Well, at one point in time, they said, nope, not anymore. And they switched over to a company called Eldor. Eldor does not sell in the aftermarket that I've seen to this point. So now if you're trying to replace a coil that was an Eldor from the factory, you're not going to be able to get a true factory coil anymore. And even the Bosch or any other brand is not going to meet those specs because, again, they're no longer the OEM. So the other thing we have to keep in mind is, especially if it's an actuator, how well it moves in response to the modulated voltage and amperage flowing through it. It's all a function of whether or not it's made to the OE spec. There's also things to consider like, does it have to respond to a bus signal or a pulse width modulated signal? Again, the more complex the electronics of the component, the less likely it is the aftermarket is going to be able to match that. So here's my example. Yes, it's a purge valve. A lot of people will criticize me for, hey, I actually did scope this and there's a reason. I've had numerous cars like this, but I want to point out and illustrate to you what is actually happening and why some of these parts can't perform. Here's where the purge valve is located, right up on the manifold. Here's the fault code information, incorrect purge valve flow, which of course can set for a variety of reasons. There's the parts diagram. We can see right there, number 24, right in the center. Whoops. Now I'm going to pull the OE part number right out of Parts Link 24. That's what I always do with European cars if it's covered in the catalog. And then I'm going to do a Google search and see if I can find a picture of the valve. So I did a Google search, found a picture of the valve, and it said Bosch on it, on the OE. So I know now Bosch is the OE manufacturer of this valve. Okay, this shop had not put an OE valve in the vehicle. We do see that Bosch makes one in the aftermarket, so they could have put an OE manufacturer in the vehicle. There's some other options, and these aren't all the aftermarket options, but I can tell you right now that if you put one of those aftermarket ones in there, it's probably not going to fix the car. So there's the picture of the OE. You can see right there, it's got the rings on it for Audi and the little VW symbol, and it's got the Bosch, whatever you want to call it, their logo. Of course, no Bosch purge valve installed, right? What if we put another non-OEM purge valve in? How many of your shops have put in multiple parts in the aftermarket and had bad ones repeatedly? Yeah, probably everybody in this room. Now, a lot of shops have done this because they're trying to save the customer money. Well, you're saving the customer money at the expense of your profitability. That's not good. We do not want to do that. Do the job once, do it with parts that work, and don't do it again, right? Here's some information. We actually do have a little bit of information from the manufacturer on what the resistance is supposed to look like. Now, I'm not a huge fan of resistance testing, mostly because resistance testing is not a loaded or dynamic test, right? This is a easy test with a DVOM, and if it's way outside the window one way or the other, okay, we're like, yeah, it's bad, right? Feel pretty confident that that's the problem. But what if it falls in that range and we're still getting the flagged fault? This is the importance of doing dynamic testing. Now, a static test, if we're talking about a purge valve, how does a purge valve work? We could test this in two ways. Lots of manufacturers are going to give us a key on engine off test with bidirectional control where it's going to modulate that valve on and off. But there's two forms of loading you have to consider in a component like this. There's electrical loading of the circuit, right? The current flow, but there's also mechanical loading of the component. The purge valve is subjected to manifold vacuum. That's a mechanical load. This is a scope waveform, and hopefully you can make it out. This is a scope waveform comparison of the aftermarket, which we can see the pintle hump on the current flow is not real good. It's not real well defined. That's not a good sign, right? Now, I also did resistance checks on it. I had an OE valve that had lots of miles on it. I had a brand new OE valve, and I also had the aftermarket. Look at the resistance differences here alone. Now, the aftermarket purge was outside the resistance window, but again, that was not a dynamic test. That's literally just with a meter. I'm not going to 100% trust that. I want to go a little bit further to be sure, right? Just like we're saying, we want to question these components. But if we look at the comparison between the OEM purge with 144,000 on it and a brand new one right out of the box, the resistance measurements are like really, really, really close, right? Now, I do some other tests. I do inductance and capacitance with a special meter because sometimes you'll find another value that's way outside the norm, right? And anytime I find something that's way off from the norm, and yes, I was spoiled because I had a brand new OEM one to compare to, but just for illustrative purposes to show you the electrical performance of this aftermarket valve was never going to measure up for a variety of reasons. You look at the waveform on the right, that's the OEM with 144,000 miles on it that I had laying around because I work on a lot of these cars. You can see the pintle hump is very well defined when it opens, right? Again, that's considered a static test because it's key on, engine off. There's no mechanical loading of the valve. Now, what about if we do that same test when the valve is mechanically loaded, AKA the engine is running and there's vacuum being applied to the diaphragm? Now look at the pintle hump. Hopefully you can see that. It looks like it's fairly ill-defined.
Oh, I can't see it.
Yeah, apparently blue shows up better than red. All right, well, we'll go back one. You can read that, but that's not amperage.
You can still see it in the depth you picked up.
Right. So anyway, you can't really make it out. You can come up here and look at it. The point is the pintle hump basically disappears completely on the aftermarket valve as soon as it's mechanically loaded because this is a dynamic test. That means we can see that as soon as it's mechanically loaded, it does not have the ability to open properly. It's not even lifting off the seat all the way. You got current flow, so we know the circuit's okay. It's not a problem with that. It's literally just not able to lift off the seat because it's inferiorly engineered. And again, it's not even entirely their fault. They're bound and restricted by patent laws. They only have so much choice. Now, if I was the manufacturer in the aftermarket and I couldn't break the patent law, I'd probably just not try to make these things, right? I'd say, you know, we can't even make something that works, so we should probably just not do it at all. Better to not do it at all than to do it really poorly, right? So now if we look at the voltage response, look at, now this was, I was not able to get the voltage capture, the dynamic capture when it's running, but even on the key on engine off self-test, look at the pintle closing. So this is in the voltage. The pintle closing on the aftermarket, the spring that's responsible for pushing that diaphragm back closed, extremely weak, terrible. That diaphragm's probably not going to seat closed at all. On the OEM, we can see that reflection in the voltage where it snaps closed. It's because that valve is shutting nice and tight like it needs to. So I wanted to do this case just to simply illustrate there's so many differences between the aftermarket components that are not made by the OEM supplier versus the ones that are, or the OEM itself, right? Something to keep in mind. And yeah, it's just a purge valve. And I know a lot of us are like, all right, why didn't you just clamp the purge line? Whatever, right? There's a lot of simple things like that. I like to do these kind of tests with scopes because it's visual. So I could show this to the shop. I do mobile stuff. So I like to have physical proof. I want evidence. I don't want to just write on a piece of paper, purge valve is bad, clamp the line off. Okay, come on. You can do a little more work than that. It's not hard. Now, if that valve was buried somewhere, maybe I would feel differently, but it's not. It was extremely accessible, easy to collect the data, easy to show the shop, hey, look, this is what's wrong with it, right? Researching the OEM supplier is really crucial here when you're figuring out what parts you're selecting to put in this vehicle. So I wanted to be able to show this because even something like a purge valve, yeah, there's not a lot of labor involved in this particular case, but that doesn't mean that when we're putting in other parts that maybe are more labor intensive, we're not going to be flushing an awful lot of profit down the toilet by putting an inferior part in that also, like what happened to Andy with the oxygen sensor, could cause you to waste a whole lot of time, right? If they'd been fortunate enough to get the right parts right out of the gate, all of that time and all of that frustration and questioning your sanity and everything else could have been avoided had they just had good parts. And I mean, I've lived in plenty of shops where I've gotten burned by the same thing. I had 7 wing window motors on Honda Odysseys in a row that were all defective. And no, I'm not going to name who made them, but I'm sure you know. But 7 in a row before the shop finally said, okay, let's get an OEM one. No, I'm not going to say. Corey's trying to get me to say. But that's the whole problem, right? They are literally trying to reinvent the wheel. And I would challenge you if someone said, hey, reinvent the wheel, but it can't be round, but it has to function exactly the same. I would love to hear your ideas for how to make that happen, right? That's not exactly an easy thing to do. So it's not entirely their fault. And I do want to point that out just because A lot of the parts suppliers and manufacturers take a huge beating, and they're trying, and some of them try harder than others. And also, quite frankly, they only have so many options that they can do. So some of the aftermarket stuff might work, some of it's not going to. And the complexity of the component is a major part of that. Another example I'll give you quickly would be Volkswagen cooling fans. Use a control circuit. There's a pulse width modulated signal that's sent to the cooling fan control module on the vast majority of the newer ones. The shutdown signal is not recognized correctly by the aftermarket cooling fan control modules because they can't mimic or emulate that same control response by the cooling fan control module because it's all copyrighted and patented. There's no way for them to reinvent it. And let's face it, like if you were an engineer and someone said, hey, you have to figure out how to get this thing to respond to that same signal. Oh yeah, and you can't cheat by looking at the circuit diagram and all the stuff they used. This is another reason why you might open up an aftermarket component and it weighs half as much as the OE because they tried to find a cheaper and easier way to re-engineer the way the circuit works. Well, that also has a lot of drawbacks, right? So just some things I wanted to illustrate because I think it's valuable. Just want to say thank you again to Mid-Atlantic Auto Care Association for letting us host this. And, you know, everybody who came to attend, I hope you guys enjoyed it. It is going to be recorded. It will go on my website, shotgundiagnostics.org. So if you want to go back and rewatch, especially his really interesting case, I mean, I think I want to rewatch it. But we appreciate everyone who participated, all the presenters. Thanks to Corey. Thanks to Robert. Thanks to Mike. And, of course, thanks to Andy. And thanks again to Ron and all of his staff for helping us make this happen. And hopefully we can do it again next time.
Hold up.
What?
Hey, don't go anywhere, guys. Guys, don't sit down for me real fast, dang it. We wanted to be like Oprah and say, you get a car, you get a scan tool, you get a scan tool, you get a scan tool, and we couldn't do that. But we do have 9 of them that we're going to ask some questions. We're going to give away these Top Scan Pros. Okay. Just out of curiosity, who in here, this is your first networked event ever, live and in person? You guys just made that much harder on me. You guys that have your hands up, put your hand down. You guys that had your hand, Ira can leave right now. You guys that had your hands up, how many of you have been in the industry for 5 years or less? 5 years is usually in you. Paul, you guys are gonna make it difficult. How long you been in? How long you been in? 1 year. Oh man, that's tough. Come here, guys. We got a couple top scans for you. I was gonna throw them, but that might be an issue.
Unlikely, but you never.
Yep, there you go, buddy. All right, what else we want to do here? We talked about this earlier. I did too.
Other ideas?
All right, yeah.
You guys was more than 40 years.
Yeah, who's got more than 40 years in the industry? Turn around.
All right, battle royale.
That seems like a setup. Who can run to the cash bar the fastest out of you guys?
Who can bring Andy a beer first?
All right, who's been in the industry longer than 50 years? Anybody? You guys are killing me. You guys are killing me. How many years?
69.
69?
69. 68.
Oh, man. The most help. No. Who traveled here from the farthest? Is anybody from past the Mississippi?
Shut up, Ira.
You guys are
Senegal, West Africa.
legit?
Legit.
Is anybody further than that? I don't think so. Well, I'm sorry, buddy. I'm sorry. Wow.
It's the one who traveled 6 miles.
Canada. What are you thinking here, guys? What are you thinking here? How many years have you guys been doing this event now? David, you know?
14, really. We started a while, 14 years ago. I've been helping since 2017. But it's been going on for out there.
Most
right,
years of attendance.
Yeah, who's been coming to this thing for longer than 5 years?
You already won. You can't win twice.
Who's been doing it for longer than Ron? I can't. It would be wrong. Who's been doing this longer than 5 years? Been coming to this event? Was it you back there? And Dave, you've been doing it longer than 5 years?
Fight for them, guys. Those things are cool.
Oh. How many years you been doing it? 5.5? I think Dave beats you. Come up here and get this. All right, what else you guys thinking? Yeah, do we got anybody else that's out of the country that travel from out of the country to come here? No?
No Canadians?
I'm from Chicago. Does that count? You
I'm
guys,
from
you both came
Canada.
from Texas? Really? Anybody come any further than Texas? Nobody came further than Texas. All right, I got 2 left. What are you guys thinking?
Who here has been to the digital version of the roundtable before? Okay, how many have you been to? You've been to a bunch. You should give him one. He's come to.
Right here?
I was gonna say that's one guy I can recognize, so he should get one for sure. All right,
We got 1 left. I don't really need that anymore. Whoever can get me a beer first would be. No, I'm just kidding. I teach tomorrow. I can't.
No beers for you.
No beers for me. What do you think, Scott? Any ideas? Who here does not have a top-down product? Has no top-down product. That did not work at all.
That was an epic fail.
That was. I was hoping less hands.
Hey, but they need to come to me and see me at the booth. I'm trying to get more units to give away tomorrow, so try and come to the trade
Stop
show.
screwing around, guys. Go buy something.
Who does mobile work? Who's all doing mobile work? Who's been doing it longer than 5 years?